ground fault can cause a ground fault circuit interrupter, or GFCI, to trip. Firstly, check for any damaged or exposed wires in the tub, motor, or pump housing. Secondly, inspect the connections at the breaker panel to ensure they are tight. Thirdly, if the tub is portable, try connecting it to a different outlet to rule out a faulty outlet. Water leakage, even a small amount, can cause the GFCI to trip. Firstly, check the seals around the tub, pump, and any fittings for leaks. Secondly, ensure the drain plug is securely closed. GFCI breakers can fail over time. Firstly, reset the breaker several times to see if the problem persists. Secondly, if the breaker continues to trip, it may need to be replaced. A 50 amp breaker is designed for high current applications. Check if any other devices are connected to the same circuit that could be overloading it. The grounding wires in the tub and breaker panel must be dry. Check for any moisture or corrosion on the grounding wire connections. In rare cases, a faulty tub or pump can cause the GFCI to trip. Contact the manufacturer for assistance if all other troubleshooting steps fail. Turn off all other circuits connected to the GFCI breaker. Wait 30 minutes for the GFCI to reset. Turn on the jacuzzi circuit only. If the breaker trips again, isolate the problem by disconnecting different components of the jacuzzi system such as the pump or heater one at a time until the tripping stops. If possible, have an electrician inspect the system for any safety hazards or electrical issues. The information provided is for educational purposes only and should not be considered as professional advice. If you are not comfortable working with electrical systems, it is recommended to consult with a qualified electrician. Working with electricity can be dangerous, and it is important to take necessary safety precautions to avoid injury or property damage. Always ensure that the power is turned off to the circuit before performing any electrical work. Use appropriate safety equipment such as insulated gloves and eye protection. Never work on electrical systems while standing in water or on a wet surface. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. Always follow local electrical codes and regulations. Improper electrical work can create a fire hazard or shock hazard. It is important to ensure that all electrical connections are properly made and that all electrical components are in good working order. Regularly inspect electrical systems for signs of damage or wear. If you notice any problems, have them repaired immediately. The electrical system should be inspected and maintained by a qualified electrician on a regular basis. This will help to ensure that the systems are operating safely and efficiently. Be aware of the potential hazards associated with electricity and take steps to avoid them. By following these safety precautions, you can help to prevent electrical accidents and injuries. Remember, safety is always the top priority when working with electricity. Do not take risks or cut corners. If you are unsure about anything, consult with a qualified electrician. Ground faults can occur when there is an unintentional path for electricity to flow to ground. This can happen if there is damage to the insulation on a wire or if there is moisture present. Ground faults can be dangerous because they can cause electrical shock or fire. GFCI breakers are designed to protect against ground faults. They work by monitoring the current flowing through the circuit. If the current flowing to the load is different from the current returning, the GFCI breaker will trip, cutting off the power to the circuit. This can help to prevent electrical shock or fire. Water leakage can also cause GFCI breakers to trip. If water gets into an electrical component, it can create a path for electricity to flow to ground. This can cause the GFCI breaker to trip. It is important to check for water leaks around electrical components such as hot tubs and pumps. If you find any leaks, have them repaired immediately. Faulty GFCI breakers can also cause problems. GFCI breakers can fail over time, and they may not trip when they should. If you suspect that your GFCI breaker is faulty, it should be replaced. Overloading can also cause GFCI breakers to trip. If you connect too many devices to a circuit, it can overload the circuit. This can cause the GFCI breaker to trip. It is important to make sure that you are not overloading your circuits. Wet grounding wires can also cause GFCI breakers to trip. The grounding wires in the tub and breaker panel must be dry. If they are wet, they can create a path for electricity to flow to ground. This can cause the GFCI breaker to trip. It is important to check the grounding wires for moisture and corrosion. If you find any problems, have them repaired immediately. Defective tubs or pumps can also cause GFCI breakers to trip. In rare cases, a faulty tub or pump can cause the GFCI to trip. If all other troubleshooting steps fail, contact the manufacturer for assistance. When troubleshooting a GFCI breaker tripping, it is important to follow a systematic approach. Firstly, turn off all other circuits connected to the GFCI breaker. Secondly, wait 30 minutes for the GFCI to reset. Thirdly, turn on the jacuzzi circuit only. If the breaker trips again, isolate the problem by disconnecting different components of the jacuzzi system, such as the pump or heater, one at a time until the tripping stops. If possible, have an electrician inspect the system for any safety hazards or electrical issues. This information is intended to provide general guidance on troubleshooting GFCI breaker tripping issues for hot tubs. It is not intended to be a substitute for professional electrical advice. If you are not comfortable working with electrical systems, it is recommended to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take necessary safety precautions to avoid injury or property damage. Always ensure that the power is turned off to the circuit before performing any electrical work. Use appropriate safety equipment such as insulated gloves and eye protection. Never work on electrical systems while standing in water or on a wet surface. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. In accordance with the 2008 National Electrical Code, GFCI protection is required for receptacles located within a certain distance of a water source, such as a hot tub. This is to protect against electrical shock hazards. The NEC provides specific requirements for GFCI protection in Article 680.42 for spas and hot tubs. The 2008 NEC Section 680.42 says that all 125 volt, 15 and 20 amp receptacles located within 10 feet of the inside walls of a spa or hot tub must be protected by a ground fault circuit interrupter. This requirement is designed to protect people from electrical shock hazards while they are using the spa or hot tub. In addition to the receptacle requirements, the 2008 NEC also requires that all electrical equipment used with a spa or hot tub, such as pumps and heaters, must be listed for use with spas and hot tubs. This equipment must also be installed in accordance with the manufacturer's instructions. The NEC provides specific requirements for wiring methods used with spas and hot tubs. These requirements are designed to ensure that the wiring is protected from damage and that it is installed safely. The NEC also provides requirements for bonding and grounding of spas and hot tubs. These requirements are designed to ensure that the spa or hot tub is properly grounded, which helps to prevent electrical shock hazards. It is important to follow all of the requirements of the NEC when installing or maintaining a spa or hot tub. This will help to ensure that the spa or hot tub is safe to use and that it meets all applicable electrical codes. Remember, always consult with a qualified electrician for any electrical work. They can ensure that the work is done safely and in accordance with all applicable codes. The GFCI breaker is an important safety device that protects against electrical shock hazards. It is important to understand how GFCI breakers work and how to troubleshoot them if they trip. This information is provided for educational purposes only and should not be considered as professional advice. If you are not comfortable working with electrical systems, it is recommended to consult with a qualified electrician. Always prioritize safety when working with electricity. A 50 amp breaker suggests a significant power draw for the hot tub, likely including a heater. Ensure the heater is fully submerged before powering on, as running a dry heater can cause damage and potentially trip the breaker. Verify the voltage rating of the hot tub matches the supply voltage. Connecting a 240 volt appliance to a 120 volt circuit, or vice versa, can cause problems. Check the wiring diagram of the hot tub. Many have specific wiring configurations that must be followed. Incorrect wiring can cause ground faults. Look for any signs of rodent damage to the wiring. Rodents can chew through insulation, creating paths for ground faults. If the hot tub has been sitting unused for a long period, condensation can build up inside the electrical components. Allow the components to dry out completely before powering on. Check the breaker panel for any signs of corrosion or damage. A corroded or damaged breaker can cause problems. Confirm that the breaker is properly sized for the hot tub's electrical requirements. An undersized breaker can trip frequently. Inspect the GFCI breaker itself for any signs of damage or wear. A damaged breaker may not function properly. If the hot tub has any electronic control panels, check them for any signs of water damage or malfunction. Water damage can cause the panel to malfunction and trip the breaker. Consider the age of the hot tub. Older hot tubs may have deteriorated wiring or components that are more prone to causing problems. Check the resistance of the heating element. A heating element with low resistance can draw excessive current and trip the breaker. Use a multimeter to check the resistance between the hot tub's grounding wire and the electrical panel's grounding bus. A high resistance indicates a problem with the grounding system. Make sure the hot tub is properly bonded to the electrical system. Bonding helps to prevent electrical shock hazards. If the hot tub has a variable speed pump, try running it at a lower speed. This can reduce the current draw and prevent the breaker from tripping. Consider using a clamp meter to measure the current draw of the hot tub. This can help you identify any circuits that are drawing excessive current. If the problem persists after trying all of these steps, it is best to consult with a qualified electrician. They will be able to diagnose the problem and make the necessary repairs. Remember to always prioritize safety when working with electricity. If you are not comfortable working with electrical systems, it is best to leave the work to a qualified electrician. Electrical work can be dangerous, and it is important to take necessary precautions to avoid injury or property damage. Always ensure that the power is turned off to the circuit before performing any electrical work. Use appropriate safety equipment such as insulated gloves and eye protection. Never work on electrical systems while standing in water or on a wet surface. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. Following safety guidelines ensures a secure troubleshooting process, minimizing risks associated with electrical systems. Prioritizing safety is paramount when dealing with electrical components and troubleshooting potential hazards.